So let's take a moment to talk about what MoonDream AI is. So this is a lightweight AI vision model that's designed to be used on edge devices. So basically when we're talking about a lightweight model, we're talking about a model that can be used on a system that doesn't have a tremendous number of resources. Think of things like IoT devices. So this is a Raspberry Pi. So imagine creating a system using the Raspberry Pi and being able to add AI vision to it. Or you may just have a very old computer, again our good old Silicon Dojo 2012 MacBook Pros, dual core processors with 4 gigs of RAM. Basically you're able to run MoonDream on a system like this and get all of the functionality. There are other AI vision models out there, but they simply require a lot more resources, a lot more modern computer, and so if you're going to be deploying them into the field, you need to be thinking about that as a hardware constraint, right? The more hardware resources the model needs, the more expensive the system is going to be to deploy. So one of the cool things about MoonDream AI is that it's such a lightweight AI vision model, you can run it on almost anything. So we've been dealing with computer vision at Silicon Dojo for quite a while now. Now normally we're using a framework called OpenCV, so we use Python to communicate with OpenCV in order to do whatever it is that we're going to be dealing with our projects. As you've seen, you can run OpenCV pretty darn well on a Raspberry Pi, so the question here may be, why would I use MoonDream instead of OpenCV? The reason that you would use MoonDream is because when you're using OpenCV, you either have to train a model in order to detect whatever it's supposed to be detecting, or find a model that's already been created for you, and that is a long, tedious process. One of those things, it's not hard, it's just tedious. You got to take a picture of the object, and then you got to put it through this whole training routine. It's a whole Megillah. The cool thing about MoonDream is you don't have to do any of that, right? Basically, you install the MoonDream package into your Python environment. You download the MoonDream model, and then you simply ask MoonDream for whatever it is that you're looking for. Are you looking for faces? You just ask for faces. Are you looking for coffee cups? You ask for coffee cups. Are you looking for cars? You ask for cars. The cool part with MoonDream is that you do not have to do any additional training. You can simply request whatever it is that you're looking for, and then MoonDream will be able to provide the information about that in the image that it sees. Again, if you've been following along with Silicon Dojo, you know we've been dealing with the OpenAI API, and the OpenAI API now has a vision model that frankly works pretty darn well. I think Claude has a vision model. Almost all these APIs have vision models nowadays. So one of the questions might be, why use MoonDream rather than one of these other vision models? And the first thing is that we can run this locally. So we can have the model literally running on our system, absolutely no network connection at all, and it can be going along doing whatever it's doing, processing information, right? Counting the number of faces that it sees, doing optical character recognition, those types of things, all from the local environment. So that's a very valuable thing. But again, you may be sitting there going, wait a minute, there's probably a model that you might have used up until this point in time if you're interested in computer vision called the Lava model. And the Lava model, that also actually works pretty darn well. And so you might be thinking, well, if I can use, there's a framework called Ollama, if I can use Ollama and I can use Lava, why would I deal with MoonDream instead of one of those? And one of the big reasons is because you're able to get the XY coordinates and the sizes of objects using MoonDream. So again, it's very important to be thinking about this. When you're coding, right, as soon as I can turn something into text, I can do something cool based off of that, right? As soon as I get words or numbers or something else in text, I can do if-else statements and all kinds of wacky things can happen. The problem is getting a picture into text. Right? And so one of the things with Lava, or again the other APIs that are out there, is you can ask questions, you can query about a picture. You can say, what is in this picture? Is it a boy in this picture? Is it a girl in this picture? Is there mountains in this picture? Tell me a story about this picture. And it'll put out all that information. And honestly, the other models are probably better for that. But here's the thing. If you say, give me the XY coordinates of every face in this image, or every coffee cup in this image, or whatever else, None of the other models will do it. At least as far as I know, up until this point in time, the models are always changing. So do caveat that. We are recording this in April of 2025. So basically, the thing is you can't get the XY coordinates, nor can you get the sizes of the objects. So the cool thing is when you get the XY coordinates and the sizes, you can do things like bounding boxes. So you can actually put a box around the objects that the vision model is seeing, so you can understand what it's seeing better. You can output to something like OpenCV actually to edit the image file based off of where the objects are within the picture. If you want to do some kind of like fogging out, or putting some kind of static or whatever over a logo or a word or something like that, that's the kind of thing that you can do when you're able to get the XY coordinates. So the thing about MoonDream that actually makes me really, really excited is this whole thing with XY coordinates. I can ask for faces or cups or whatever else. It gives me the XY coordinate, it gives me the size of the object. That is something I can do some cool stuff with. So when you're running MoonDream locally, there's going to be basically 4 models that you're going to have to concern yourself with. We have the 2B model and the 0.5B model, and then there's 2 compressions of those models, right? So the 2B model, basically the size of that is approximately around 2 gigs in size. So when you go to download it, it's going to be about 2 gigs in size. If you do the 0.5B model and you download it, it's going to be around half a gig in size. Then we have what are called the 8int and 4int versions. So this is basically how these models have been compressed. The 8int is going to be the largest and the best quality for results. The 4int is going to be the smallest with the worst quality for results. Again, the thing that you have to be thinking about is what hardware resources do you have for your project? Do you have a Raspberry Pi 4, Raspberry Pi 5, a Raspberry Pi 0? Do you have a MacBook from this year with 64 gigs of RAM, that type of deal? Those are the kinds of things you have to think about with the different models that you'll use. What I will tell you for the projects that I'm going to be showing you is the 2B 8int is the best. It's the largest, it's the best. As long as you're running a computer that has been built within the past decade, it should be fine for you. Basically, what you need to be thinking about then is when you're thinking about the environment you're going to be deploying your project that uses MoonDream into, then you start tweaking down with the model size to see basically how far you can go down and still get the results that you're looking for the performance that you want. So we're going to be using 2B 8int for our projects. The smallest version is 5B 4int, and I can tell you with using that smaller model, it works. It works. It's a wee bit quirky. Now another thing that should be really cool, but I find it to be a wee bit quirky, is that MoonDream should have the ability to output as structured text. So what we mean by structured text is an issue that you run into when you're parsing the return that comes back from any of these models or anything is basically how do you get your script to read it, and not just read one instance of it, but if these returns are coming one every second or 20 per minute or whatever, and you're getting them, how can you make sure you're reading all of those returns properly so that your script is able to fire off whatever events it's supposed to fire off, right? So if I'm getting like a caption back, or if I'm just asking a normal query from MoonDream or from any other AI vision model, one of the problems is the text that I can get back may be technically correct, but how do I get my script to read it properly? So the cool thing with structured text, we're talking about JSON, we're talking about XML, or we're talking about CSV, is the idea here is that MoonDream should be able to send you back the results within a pre-formatted structure so that it'll be very easy for your script to be able to parse, which is, again, another absolutely great thing from MoonDream if it wasn't a bit quirky. I have played with this. I have used their examples. I do need to reach out to them to figure out what's going on. I can get text that comes back in a structure It's not exactly the most useful thing in the world. So again, we may have a class in this particular series on how to bring back a structured text. What I will tell you is the results that I have gotten are, again, technically correct, but absolutely not useful. Another piece of functionality for MoonDream that frankly I have not tested but actually sounds really cool is the idea of gaze detection. So basically what's supposed to happen here is when you have an image and you have people's faces and they're looking somewhere, MoonDream is supposed to allow you to figure out what somebody is actually looking at. This could be a very valuable thing for your particular projects. I've looked at it a little bit. I have not played with it a lot, so I do not know how functional that actually is, and we may or may not actually have a class on it going forward. So one of the big things to understand about MoonDream AI and any of these AI projects is they are constantly trying to improve them. Every day, every month, every leap year, I don't know, at a certain amount of time, all of these projects should improve at a quite measurable degree. So if there's something about this that's not really working well for you now, if you come back in a little while and basically download their new models, that might be better for you. One of the things that I notice now is that when you run MoonDream just using the Python module that they allow you to download, it's only going to be running off of CPU. So if you know anything about these AI models, the GPU is where these AI models perform the best. CPU is where the models perform the worst. And so for whatever reason, at this point in time, if you're running MoonDream locally using their Python module, you're only going to get the CPU in order to do the image processing. And it's kind of interesting what the results are. Again, when I tell you that the MoonDream can run on a 2012 MacBook Pro with 4 gigs of RAM, that is really impressive, right? So I can run it on here and it will give me the results that I want. It can caption an image, it can give me XY coordinates, it can do all of that fancy stuff. The thing is, my daily driver, the main computer that I use, is a 2023, so a year and a half old for me, a year and a half old MacBook M2 Max, right? So it's got 32 gigs of RAM, it's the M2 Max processor, whatever that actually means in the Apple world, the whole 9 yards. And again, the quirky thing is, it's not that fast. Again, I'll show you as we go through the classes in here. And so when we do this, this is actually coming from my M2 Max MacBook Pro. And what you're going to see is that the results that you get back, even on a $3,000 computer that is a year and a half old, is not exactly as fast as you would think from a product that we have been told is designed for edge devices. So hopefully this kind of, the performance will get better in the future. But again, with all of this stuff, when you're thinking about your environment, the functionality, like what MoonDream is able to do with the X, Y coordinates and all that kind of stuff is absolutely awesome, but you are going to have to look at the speed of its performance to determine whether it's actually usable in your environment. So that's why if I'm thinking about using MoonDream, I'd be looking at it for prototyping and testing. As a first step or as a second step, it is absolutely awesome. It gives you a lot of functionality. But again, going from the lab testing educational environment and jumping right into the enterprise actual production world, I am concerned about the performance and some of the other kind of quirks with it. So this is something that you're going to have to think about. Again, one of the things that you can do is you can do testing and play around, create an MVP or a prototype using MoonDream. And if you know like the specific, objects that you want to detect, after you've made sure everything else works properly, it might be worth it to you to then go to OpenCV and train a very specific model for the exact things that you're looking for, right? The performance there might be a lot better. So you use MoonDream in order to do the testing to basically get the sign off from the CEO. Once you get the sign off and the check from the CEO, you then go do the hard work to basically train your own model. That's one of the things that you might be thinking about with MoonDream. But it's a pretty cool product, and I'm going to be showing you how to do it in these next classes.